All right, looking at question number 6. The graph of the quadratic function y equals g of x is a parabola, and its vertex is located at 3, -2. The graph also passes through the origin. Which of the following must be equal to 0? So let's take a moment and make sure we understand these answer choices. These choices are written using function notation. So they're saying g of 4 possibly equals 0, g of 5 possibly equals 0, g of 6, and g of 7. This g of 4 is saying if we were to take this function and evaluate it in input of 4, would the output be 0? That is the question we're asking. If we were to plug in the value 4 for x, would the output be 0? If we were to plug in the value 5 for x, would the output be 0? Similarly, if we evaluated the function using the input 6, using 6 for x, would the output be 0? Or if we used 7 for x, would the output be 0? So that's the question we're trying to answer here, using function notation. All right, so let's go ahead and sketch maybe a little rough graph of this particular quadratic. We don't know very much about it, but we do know that the vertex is located at +3, -2. So just making a little rough sketch on our paper, I'm going to go over to my paper and I'm going to go down 2 units on the y-axis and right 3 units on the x-axis. And I'm going to place my vertex right around here at x equals 3, y equals -2. And they also give me one more additional piece of information. They tell me that this parabola passes through the origin, and the origin means the same thing as the point 0, 0. So I also know that this parabola goes through this point right here. Okay, before I sketch a picture of this parabola, I'm going to remind myself that the vertex actually has associated with it an axis of symmetry. And remember, that is a vertical line that is located at x equals +3. That cuts this parabola directly in half, and the parabola is symmetrical on each side of that axis of symmetry. From here, I'm going to do my very best to kind of sketch a rough model of what this parabola might look like. It certainly does not have to be perfect. So something like this will be perfectly fine. Alright, so here's where we're really going to take advantage of that axis of symmetry. We actually already know one of the x-intercepts. We know one of the x-intercepts is located at the origin, which is the point 0, 0. We know that the parabola is symmetrical around this vertex, which is located at 3, -2. So what we do know is we know one of the x-intercepts is 3 units away from the vertex, or the axis of symmetry, on the left-hand side. This means that in order for the parabola to be symmetrical, which we are assured that it is, the other x-intercept must also be located 3 units away, this time on the right-hand side. That being the case, we can predict very easily that if we had to go 3 spaces to the left to get to one of the x-intercepts, we'll have to go 3 spaces to the right to get to the other x-intercept. So we'll have to travel 3 more spaces from x equals 3 up to x equals 6. And this will be located at 6, 0. We know the y value is 0 because we're located at the x-intercept, where y equals 0. So going back to our original question, we know that when the input, the x value is 6, the output must equal 0. So this will be answer choice C is the correct answer.